Okay, thank you for the request to go through this question here. It's quite a tricky one. It takes a bit of understanding. Let's read it together. So, an apocryphal story. If you don't know what apocryphal means, that means an unlikely story. Tells us that an Oxford University examination question was once set to physics students as follows. How would you use a Fortin barometer to measure the height of the Clarendon Building? Okay, so I guess one thing this question's just asking you to do from the beginning is just try and dismiss things outright. You don't need to know what a Fortin barometer is, or what the Clarendon Building is, or what an I can't even pronounce it, apocryphal story is. Don't need to know what any of that is really for this problem. What you need to recognise is that this is to do with an object being dropped off a building with constant gravity, so it's a kinematics mechanics problem. Right, so what's the first part of this problem? One student offered the following answer. Take it onto the roof, drop it from the edge and time its fall. Using his method and a constant acceleration model, what height would he conclude the Clarendon Building had if the barometer's time of fall was t1 seconds? Okay, so let's do that first part. So there's a constant acceleration. So we can do a sketch of this problem. I think it's definitely going to be worth doing a sketch of all this to try and get our heads around everything that's going on. Okay, so h1 has been defined as the total height of this building. So there's our Clarendon Building. What are we also told? We're told to take care that gravity is our 10 meters per second to minus 2. And it's a constant acceleration, and so we should probably write out our SUVAT, shouldn't we? So SUVAT, what can I say? Well, S is the h1 that I'm ultimately trying to express. U, it's just been dropped, so we can we can simplify that it's got no initial velocity, so U is equal to 0. V, we don't know. Maybe I could call that V1 for the sake of things, the velocity it has at the end. That's my V1, that's my U. A, we know, is 10, provided we take that down is positive, and I'm going to take down as positive, seeing as that'll make most of my values positive here. And T, we don't know. Maybe I'd call that T1 as the time it takes to get from 0 to the floor. Okay, so let's have a think about this. I'm ultimately trying to find an expression for S for this question. So I need to think through my SUVAT equations, my SUVAT formulas, and which of these is going to be the most useful. Well, I think using S is equal to ut plus a half at squared is the best formula to use for this, because if we remind ourselves about the question, it's asked us to, it's told us this happens in t1 seconds. So if I express this in terms of t1, my u I know is 0, so this is going to simplify to 0. My acceleration I'm given, I'm going to be able to substitute my values in and express this in terms of t1. So that's what we can do. So my S is h1, that's equal to 0 times my t1 plus my half times my acceleration, which is 10, times by my t1 squared. So I can conclude that my h1 is 5t1 squared. And there we go. And then this question gets even more tricky. So let's have a read through it.